Hello there. You are welcome once again to New Focus Approach to Mathematics Basic 8. This is the revised edition. And in this video, we are looking at using real life objects to explain the concept of gradient and then further solve questions with regards to gradient. So when we talk of gradient, we are talking about slopes. And you can see from here the bicycle rider trying to ride on a very steepy slope. And you consider this one to still see slope, but comparing this slope and that slope, you can see that there's a difference between the two. One has higher slope or higher gradient, and the other one is low gradient. Now, in real life experience, if you see roofs, okay, you see a lot of slopes, gradients. So slope simply means gradient. So the slopes that you see here, it comes with an intention. It's not just for fun. They create slopes so that water can easily drain, okay, when it rains. And then you see on our roads, we see gradients. You see gutters always at the edges of the roads. They will tilt the road in such a way that there will be a slight gradient so that water can easily slope down to the gutters. If you go to our homes, staircase, we have slopes. Okay, on the hills, when you're climbing the hill, you see a very good slope, or let's say gradient, right? And so we have gradient everywhere, right? Now, let's study more about gradient. When we talk of gradient, we are talking about slopes. And how do we calculate slopes or gradients? We can do this by first looking at the horizontal distance and the vertical distance, and then we use it to calculate our slope. So we normally say change in y over change in x will give us the slope. And so if you look at this question very well, or this diagram very well, you can see the point here is 2 and 1, whilst the point here is 7, 4. Now, change in y simply means between the point 1 here and then the point 4 here, what is the difference? Okay, the difference, it will be 3. And between the point A here and the point B here, what is the difference? That is the change in x. And here the difference will be 5. And so if you're able to divide the difference in terms of the y-axis over the difference of the x-axis, then you define the gradient of the line. Is that okay? So in a nutshell, we are saying that gradient of a line, which we normally use m to represent, is defined as change in y, that means y2 minus y1, over change in x, x2 minus x1, where the y2 and y1, the maximum point here and then the minimum point here becomes the x2 and x1, and here the minimum here, the maximum becomes x2, x1 respectively. Now let's look at another example where the line goes opposite direction. Compared to this one, the previous one, we had the line going this way, but then when the line goes that way, it changes. And then we are seeing that the gradient of this line is going to be negative. Why? Because the point here, which we have as 1, 4, that is for the B, and that of the A is 6, 6, 2. Now, if we do change in y and change in x, we are going to have y2 4 minus 1 over x2 2 minus 6. And so we are going to have 3 over negative 4. And so that becomes negative. And so anytime a line goes this direction, gradient is negative. If a line goes this direction, gradient is positive. What if the line becomes horizontal? What will happen to the gradient? We see the gradient will be 0. Why? Again, the point here we have 1, 2. And the point here we have 7, 2. Now, if you do change in y over change in x, if you say y2 minus y1, we have 2 minus 2, and then 7 minus 1. The top will give you 0, the down will give you 6. And 0 over 6 is the same as 0. And so anytime a line is horizontal parallel to the x-axis, we always get our gradient to be 0. Good. And then what if the line becomes vertical, and it's parallel to the y-axis? Vertical parallel to the y-axis. Here we'll see the gradient will not exist. It will be undefined. Why will it be undefined? again, the point here we know is going to be 3, 5. And then the point here is going to be 3, 1. Again, if I do y2 minus y1, I'm going to have 5 minus 1 over 3 minus 3. And then I'm going to have 4 over 0. A number over 0 is always undefined. Okay, and so anytime you have a vertical line parallel to the y-axis, we'll say its gradient is always undefined. Okay, that's beautiful, right? Now let's take a few examples and see. Let's say you are to determine the gradient of the line that passes through the point 4, 3 and 6, 7. How will you find the gradient? So here we have to define our x1 and y1. So if I call this x1, I'll call this y1. And if I call this x2, I'll call this y2. Take note that you can change them. You can call this one x2, and here becomes y2. Here will be x1, here will become y1. Whichever way you go, you get the same answer. But then you ought to be very careful that you don't call this x1 and call this one 2x1. No. Because for every coordinate, we have x and y. And again, don't make mistake by calling this one x2, then you call this one rather y1. Call this one x1 and call this y2. That also will give you a wrong answer. So you must be careful how you label them. So if you call this one x1, call here y1. If you call this x2, call here y2. In that case, your gradient is supposed to be changing y over changing x will be equal to, so y2 is 7 minus y1 3 over x2 6 minus 4. And so we can simplify this as 4 over 2, and the answer is 2. So the gradient of this line that is passing through the point this and that will be 2. Very steep gradient, right? Then again, we have the slope of the line, a line that passes through this point and that point is 2. Find the value of y. Okay, we know that the gradient has been defined, and we know gradient to be y2 minus y1, x2 minus x1. So if the gradient is 2, what is our y2? I can call this y2 and call this y1. So we have y minus 2, all divided by, then once I call this one y2, I must call this x2. So 2 minus negative 3. So this implies that I have 2 is equals to y minus 2 over, now here I'm going to have 5, right? Good. If I do cross multiplication, I have y minus 2 is equals to 10. That is 2 times 5 and 1 times that. And again, having y is equals to 10 plus 2, then our y will be equals to 12. So it means that for this 2 point to have a line with a gradient of 2, y must be 12. Let's try last example and see. Let's say we have this graph for us. It's a graph of volume of water in a tank with time. So maybe the volume keep on increasing as time goes on. We want to find the gradient. It has given us a straight line. And look at the nature of the line. It means our gradient should be negative, right? But then how do we get our gradient? We need to know the point at least. And because all the 3 points here lies on the same straight line, any 2 points you pick will give you the same gradient. So let me pick the point here, which of course will be defined as 1, 15, and pick this point, which is also 5, 5, 3, right? So to find the gradient, again, our gradient will be y2 minus y1. So I will call this one y2, which is 3 minus y1, 15, divided by 5 minus 1. And again, we have 3 minus 15 is negative 12, divided by 5 minus 1 is 4. And so we realize that our answer is going to be negative 3. Very steepy gradient. And I said it earlier on, I'm going to get negative gradient. Right. Okay, so I want you to go ahead and solve more questions in the books. Right. And in our next video, we'll be looking at more questions in line with gradient and equation of a line and so on and so forth. Thanks so much for watching.